Hi, welcome to our math. Today I'm doing a series of videos on higher order polynomials. In this video, I want to find a function with the following given zeros. For the first one, we have -9, 0, and 4, which seems not too horrible. The next one looks a little bit more challenging. So let's start with the first one. 0 means we have an x minus 9, that means x equals -9, and this means x equals 4. So this is x equals 0. I guess we can put that in. So x equals 0 is just x. X minus 9 means we have an x plus 9 equals 0, and x equals 4 means we have an x minus 4 equals 0. So our factors are x times x plus 9 times x minus 4 for our function. I'll add the function notation, the f of x, at the end. So I am going to start off with multiplying out the binomials. I am going to use distributive property with stacking. X squared minus 4x plus 9x minus 36. This gives me x squared plus 5x minus 36. And then I'm going to distribute that x in. So f of x equals x cubed plus 5x squared minus 36x. And we have our function. All right, that's not too bad. Multiplying two binomials, distributing an x, and we're done. Let's talk about this one. First of all, we have to not forget that this is a fourth degree. That means essentially we have a 0 in here as well. That is just a hidden extra 0. So we really have that we'll bring in later. What's given to us is x equaling 2, x equaling the square root of 5, and x equaling negative the square root of 5. In all honesty, anytime you have a square root 0, or later on an imaginary, a complex 0, they always come in these pairs of a positive and a negative. And once we start solving this, you'll see why. So we have x equaling -2 when we bring this over, x equaling x minus 2 equaling 0, x minus the square root of 5 equaling 0, and x plus the square root of 5 equaling 0. So we just wanted to bring each of these over so that we would have x minus 2, x minus the square root of 5, and x plus the square root of 5. And if we want, we can bring this extra x down so that we have 1, 2, 3, 4 x's, and then the fourth degree is just taken care of right away. All right, so then I am going to start with the stickiest bit. You can't multiply multiple numbers at a time, so we're going to do 2 at a time. I'm going to do exactly what I did over here with my distributive property with stacking. X times x is x squared. X times the square root of 5 is x square roots of 5. Minus x square roots of 5 minus the square root of 5 times 5. Those cancel. I'm left with x squared minus the square root of 25. Now, this is why they come in pairs. The ugly goes away. And this, if you look at this, the square root of 25 is 5. This really becomes minus 5. Now, if I distribute this in, I have x squared minus 2. And so now this is what I need to multiply out. X squared minus 2x, x squared minus 5. For all of you who are mentally saying you forgot the x, thank you for letting me know. So I have x squared minus 2x, x squared minus 5, and I'm going to do exactly what I did here and use that distributive property with stacking. So I'm going to bring this x squared in, and I'm going to get x to the 4th minus 5x squared. Now this is going to give me an x cubed. So I'm going to write it over here, minus 2x cubed, because I want to, the whole point of stacking is stacking up like terms, and that cubed isn't a like term. And then I'm going to get this, which is a plus 10x. You're like, what's the point of stacking when none of them are like terms? And that is a very fair question, but it allows me to really look at all my terms, and I'm going to say, I'm going to make this g of x, and I'm going to put x to the fourth. I'm going to put it in descending order, so I'm going to put the minus 2x cubed next, then this one minus 5x squared plus 10x. So I have them in descending order, and it's kind of nice to see them when they're kind of spread out like this. All right, I hope you've enjoyed this video. Please subscribe to my YouTube channel, and I'll see you on the next video. Thanks.